OK. Čaute. Ja som Michal. V prvom rade by som sa chcel spýtať, koľký z vás chcú, aby to bolo v slovenčine a koľký z vás chcú, aby to bolo v angličtine? Rozmýšľal som, zvažoval som, že koľký z vás by mali problém s tým, keby to bolo v angličtine.
Ukáž sa.
Ja sa radšej pôjdem v slovenčine.
Dobre, takže vás príliš málo, máte smolu? Bude to v angličtine. Okay. So, hello everyone. I'm Mike. That's my Twitter handle if you want me. And I'll be talking to you today about splitting an application from a monolith to something that's a little bit more manageable, and what our experience were with doing something like that. So, my sort of about page for this talk is a little bit simple, but I think the content is enough to get us started, maybe talking afterward.
Slovenský mikrofón.
Hello. Testing. Okay. So I'll be talking about my experiences with working at a company called Michal and a product they call Kamado, and what were the most important decisions that went to why switching to services instead of a monolith. Then I'll list out some good experiences, some bad experiences, and some tips on how to do it and how to maybe do it a little bit better than we started out and how we worked. So, how many of you have heard about PPC or pay-per-click advertising? Okay, a few hands. That's good. Yeah, well, so for those of you that don't know, AdWords or search ads is something that pops up at you from Google when you search for something. And the way you manage this is through something like this. It's the AdWords interface, and it's not necessarily bad per se, but if you need to have a lot of manage a lot of ads and a lot of keywords, it's becoming a lot of pain. So that's basically what our product does. We usually serve large clients, but we can also serve mid and small clients who need to advertise on the Google platform, who have a lot of products, and we help them basically cluster their keywords, discover some attributes within them, and generate meaningful ads that perform better than whatever they could do by hand or our competitors could do. This is our current infrastructure. It first started off with just one monolith, and currently we have sort of split the monolith or extracted some stuff out into 3 services. And that cap thing is the team I'm on, so those 3 services is something that I also work on. And we have 3 more services on the way. There's another team that provides data for us, and that has 5+ services on top of a data warehouse. And all this is, last time I checked and I talked to ops, we have 100+ VMs. So this is quite big, and I think our learnings are quite valuable. So why do we sort of say, yeah, we'll go for services and not stay with the monolith? Well, the first thing is cognitive overhead, or if any of you have worked on a large application, fitting it all into your feeble little mind is not really doable, and it can get to a point where in order to do anything you have to sort of two-day code archaeology in order to do anything useful. So that sort of was one thing. The other thing was ultra slow app and tests. Currently, our whole test suite runs in a little over 40 minutes on a local box. It runs in about 7 minutes in CI. So that maybe is a little bit too slow, at least it's for me, because I start checking Twitter whenever I need to run more than one test. So that is a little bit annoying and sort of doesn't work with a big app. And yeah, we couldn't really upgrade anything just because of the sheer size of the app was causing us to do a little bit of a small little hacks here and there that sort of ultimately end up with us not being able to upgrade any of the dependencies because it just was the dependencies and the code changes were all over the place. So yeah, we basically said, okay, let's do this, and these were some of the good things that that I noticed that work. I think most important thing is firm boundaries. Usually when you have that big one application, you have somebody say, yeah, let's leak this abstraction just a little and then just a little bit more, and yeah, this doesn't really work when you have a separation that's on the HTTP layer where you can't really leak anything except the API, which is public. So that kind of forces you to have those firm boundaries and not leak something all over the place. Yeah. The other thing is language doesn't really matter when you start using services. When your communication protocol is HTTP, you can re-implement a service with anything you want. We had no problem trying Clojure or something like that in a small little service, as long as it spoke something that the Ruby, which is most of our stack, Ruby clients could talk to. Didn't really matter which language it was. And also, it's fast tests, usually within a few seconds. Yeah, that's no issue because when you split something into smaller parts, you have fast tests. And also, since we work in multiple teams, you have clear ownership of a part of code. It sort of goes back to the firm boundaries thing. When you have separate services, you could designate them to separate teams who are then responsible for them. And you don't get that situation where you don't really know who to talk to, who to approach when you need to consult some part of code because you always know who's responsible for which service. There's also some bad parts that we saw. The most important thing, or the worst part that we saw, and that is the most annoying, is there's no good way to integration test when you have services lying around. You could spin them up, wire them up to talk to each other, but then you're sort of replicating whatever integration or staging environment you have. So that's why we decided to basically use them and have some smoke tests around that to prove that nothing is down. But there wasn't really a single place to go to have an integration test. The services themselves are usually very well tested in isolation and in the scope of the service, but the thing as a whole, there's no clear way to do it, and the only thing that sort of works are smoke tests for us. There's also a negative and also maybe a positive, because you have to start thinking about stuff a little bit in detail before you start doing them, is that there is considerable overhead. You have to think about deploying the service, configuring the service, hooking up to other services. The overhead is usually not that big once you have some of the practices I will talk to in a little while, but it's still there. and you don't really want to be starting out using services because of this point. So yeah, without further ado, here are some tips that we exercise and do within most of our services, if not all. This is maybe sort of...
Can you explain the considerable overhead? I didn't quite get it.
So considerable overhead in terms of costs. So you have to have the infrastructure. That's one thing. The other thing is you need to have all the services talking to each other, which means you have to have facilities in order for them to talk to each other, right? If you have just one big monolith, your language is your facility. But if you split stuff up into services, you have to wire them up, have them talking to each other. So there's some development time involved in that, right? Does that answer your question?
Yeah.
Okay. So the first sort of thing, once you get the basics down, is you start to explode services. And we've seen this sort of. We had sort of every idea was a service. Don't really, or try to minimize this as much as possible, because then you end up with millions of services which where none of them really do anything useful. So maybe try to have them have a few ideas within the service, not just a idea. But yeah, it's just something that we saw that there was a little bit too much services. If possible, use REST and JSON. It's something that's well supported across languages, across frameworks. So you just use it, don't have to really think about it. But there are some exceptions to this rule, which I'll be talking to on the next slides. I mentioned the infrastructure, and maybe one thing to the question is also you need to monitor all of them, right? So you have to have at least New Relic. We also use server density for most of our server monitoring needs. So things like memory usage, disk usage, CPU usage, things like that. You have to monitor all these things. So that's what I also meant by overhead. One thing that panned out really good for us is client gems and libraries. Since our stack is mostly homogeneous, which means Ruby and Rails, we usually ship each of our services with a client gem, which you can just plug into your Ruby app and use. And this is one of the, I think, biggest wins when it comes to keeping your costs, at least your setup costs, down. Also have some configuration conventions. We usually just have YAML files in our projects, which we load into the individual client gems. This usually works pretty well, but the most important thing about that last point is that you have to have these conventions. It doesn't really matter what. What matters is you stick to them. So that you don't have subtle variations in between services and how you configure them and how the client gems sort of work. This is one thing that is pretty well known from databases, but I will be, in terms of services, sort of thinking that they know about the world and know what the state of the world is. You could end up in a situation where you have one service that's providing something for another service, and the second service assumes that the first service has a piece of configuration or a piece of information rather, and that piece of information may not be there. You may then end up getting into trouble where the second service, which is dependent on the first service, fails. And if this is a background task that's trying to finish by morning so that your customers can have fresh data, you have a lot of issues there. So what we've run into one of these issues quite recently, and the outcome basically was to have a central kind of repository for information. We haven't really fleshed out the details yet, but this is something to keep in mind. To not have information split across services without having them some kind of mechanism to sync them. Ideally, you'd like to have that central piece of infrastructure which keeps all your state of world data, or whatever you want to call it. This is the next point where you could end up with JSON not really suiting your needs. If you have a service that's trying to consume something from another service and that data is literally millions of rows of data, you might as well just forget about JSON, because you're gonna hit server timeouts, and you can't really get around that even if you use streaming or whatever. So in this case, what ended up working really well, and what we sort of use, and Google even uses this for their reports, is CSV, plain old CSV, which is gzip. You can transfer this, parse it easily, and something that hit our 1 hour server timeout and couldn't really finish can now be transferred within 1 minute. So that's quite a bit of improvement. So yeah, this is just something to think about if you really need to transfer a lot of data. This point is something that you need to do once you get a lot of services and you have a lot of different infrastructure dependencies. And you sort of run into the issue where it works on your machine, but you can't really get it to CI, or you need to install 50 different packages on your CI. And there, it sort of always blows up. The way to solve this issue is to just use Docker. I think everyone is familiar with Docker in this room, or at least I hope. Hands up who doesn't know what Docker is. Okay, just a few hands. Approach me afterwards. So I think this is sort of a moot point then. Use Docker, it's awesome. Don't really have enough praise for it. And also, this is sort of a given then. I also mentioned this CI thing. You need to automate your build and deployment. Either use a service or you roll your own like we do. You need to have a build and deploy pipeline where you can just deploy services, because if you have just one app, you may swing it by deploying it from your local machine, but if you have a lot of services that you need to deploy, you cannot handle the complexity, and each one of your teammates will thank you if you set up a build and deployment pipeline that they can just click, click, click and deploy and don't have to think about it. So, to wrap up, I wanted to answer one important question. Should you actually split your monolith into services? And the answer, I think, is two ways. You first need to grow to a certain point to actually appreciate these things, because if you start out this way, you will not, you cannot predict what your services are going to be, and you end up abstracting too early. So what I always recommend doing is feel a pain where your code base is too big to manage, you cannot wrap your head around it, and then start thinking about extracting stuff out, not just roll a few services and see what happens, right? So we need to extract stuff instead of trying to abstract too early. Yeah, so that's about it. Those are our experiences. Are there any questions or comments? Oh, quite a few.
Okay, you mentioned that you pretty much support a central repository for data, right? So the services do not work with their own pieces of the schema, right?
Okay, so
yeah, but do you also support sort of a central orchestration of the processes, or do you prefer rather choreographic approach where everybody can be dependent on anyone?
So the first part was that sort of a comment where we support a common infrastructure. We don't do this yet. We just saw the pain and we are trying to address it, where we sort of implement something which has the information which other guys can ask. Okay, what's the state of the world? The second was a question if we sort of prefer an orchestrator, right? Or if we prefer each of the individual services talking to any one of the other services. We do the latter, where we allow any service to talk to any service, basically. We don't really have an orchestration layer where we don't really need to have one, actually. It's... It's the orchestration is essentially implied within each of the actors. So whenever someone needs to, they call somebody else to get whatever they need. Essentially, what we basically do is on one of the earlier slides, we have the application which has services which do talk to each other, but mostly it's about getting the right data, and that is another layer of services which sits on top of pretty elaborate data warehouse, which sort of gives us a lot of flexibility in that way. So there's two tiers of services, we could say.
Yeah, you mentioned that you are using CSV now.
Not always.
Not always. So anyway, if you are using it, where is the schema defined? You know, it's
in the client gem.
It's like fragile to me.
Okay, so the question is, if we are actually using CSV, where is the schema defined? So first, so to answer, we use it actually for a few endpoints that actually need to transfer a lot of data, because mostly it's not that much, but sometimes you do end up trying to transfer millions of rows of data. And then we have the first column is your schema, right? In your CSV, it's your column definitions. And we have those client gems that I mentioned. So the client gem basically reads the CSV, transforms it into a hash, and then gives you an iterator where you can just transparently iterate over whatever is there. So you have to basically know what's in there in order to use it, but that's kind of implied, right? Yeah, sure. Sure.
You mentioned CSV. Why not some binary protocol like protobuf?
Okay, so question was why CSV and not protobuffers? The answer is simple. We at that point didn't really have much experience with protobuffers, and it felt like protobuffers or other binary protocols, it felt like they weren't ready for prime time, and CSV is something that just worked. So we basically opted for the pragmatic approach where if something just works, don't fix it. That's the reason. There's no other... we actually were looking into protobuffers as to use in our client gems. It's just we haven't gotten to a point where we have it tested, we can just roll it out, right? So it's also a matter of capacity where we didn't really have the resources to do it.
100 virtual machines.
Okay, so another question was why 100? To be completely honest, I do not know. This is something that I just asked one of our ops guys, and that's a number that he came up. It's just 100 plus boxes. As far as I know, you have to think about redundancy in terms of Postgres master slave replication. You have to have a lot of instances for, say, Mongo in order to not lose data. And also, one thing that comes to mind, what we do with our services usually is have 3 environments. So maybe to give you a little bit of a background story, we first deploy to an integration or a staging environment, so that's 2 environments, before we deploy to production, just to test things out and have a sandbox to test things on. So this contributes to the virtual machine explosion, because in order to put any service in production, you need to have at least 3 virtual machines. Is that satisfactory or? Okay. Any other questions?
What was the performance hit for moving to web services over the monolith?
So the question is, what was the performance hit? Moving from monolith to web services or trying to extract stuff into web services? To be honest, I do not have any numbers I can share with you. The performance in terms of how we can scale things and how it actually works is fine, I would say. It's not, we didn't do any measurements because there's no real good before and after, because we still have that big application there. It's just we extracted a few things from it in order to not keep piling on things on top of it. So usually it's also new stuff that we try to do services for. So that's why I don't really have any numbers to share with you. But the performance is fine. We have no real issues. And to be honest, performance wasn't really an issue before. So it's mainly for the reasons I mentioned, where you have those firm boundaries, and you have the firm separation, and you have the ownership. Any other questions? One more?
Maybe I haven't heard this, but what's your development stack, like language?
Okay, so the question was, what's our development stack? I think you're referring to our default, right? What we usually use when we don't have any special needs, right? So the default is Ruby, Rails, and Postgres as the backend. We use Redis as our backend for our custom job system. So we use something that we build on top of Sidekick. And I think that's about it. So that's a pretty standard thing these days. We do have a few services that are written in Scala. I can't tell you about how exactly they work because I haven't really worked on them. I just know that they're there. And there was a closure prototype. And yeah, but the default stack is Ruby and Postgres and Rails.
What about frontend?
Oh, what about frontend? That's Backbone and I think something called Marionette that's on top. But I'm not a frontend guy, so I cannot speak for the frontend guys. Any other questions? So if there are no questions, I think we can call it. If somebody wants to talk to me offline, I'll be at the bar.